Hello again, math students. Now that we've learned about finding square roots and cube roots, now we're going to see why we would want to do that in here, because we're going to actually be solving equations that have squares and cubes in them. So we'll have to use square roots and cube roots to get rid of them. So in this problem, my equation says x squared equals 25. To get rid of squaring something, we're going to use the inverse operation, which is going to be taking the square root. So here's what our work is going to look like. If I start with x squared equals 25, I would draw in the square root sign on each side. And I want to talk about this in just a second. And then we would take the square root of both sides. So we know that if that plus or minus sign is in front, we know it's just going to be a plus or minus sign for our answer. The reason that that plus or minus has to go there is because when I looked at my original problem, I said some number squared gives me 25. Well, that answer could have been 5 because 5 times 5 is 25, but it also could have been negative 5 because negative 5 times negative 5 is also 25. So when we draw in a square root sign, then we also need to put that plus or minus sign in front of it. So if you're the one drawing the square root sign, you have to put the plus or minus sign in front of that square root sign. So in this, showing our work, and this is why you've got a paper copy of this worksheet, is because I'm going to expect you to show your work. I would take the square root on both sides, and because I drew in the square root, I put in the plus or minus. So here, the square root and the square just cancel. That's my x. We knew that it was going to be plus or minus, and the square root of 144 is going to be 12. So 12 squared would work, and negative 12 squared would also work. For this one, when I take the square root on both sides, to get rid of the square root, plus or minus. I know that the square root of x squared is just going to be x. I know that it's going to be a plus or minus, and I kind of drew over that decimal, but I know it's going to be a decimal. And since there are two numbers after the decimal, my answer will have one number after the decimal. The square root of 9 is just 3, so this is going to be 0.3. I know that some people really, truly think that it's going to be 0.03. But if you think about how that multiplication works, 0.03 times 0.03. Yep, 3 times 3 is 9, for sure. But I've got 1, 2, 3, 4 numbers. That's what I would get if I squared that. But if I just have 0.3 times 0.3, this would be 3 times 3 is 9, but I've got one number here after the decimal, so 2 places, 0.09. That's what I needed. And for this one, again, we're not worried about fractions because I'm giving you nice numbers for this. So to get rid of the square, I'm going to use the square root. I'm going to sneak in that plus or minus, so I'm going to get that x equals square root of 121 is 11. The square root of 225 is 15, and then I need the plus or minus in front of it. Now remember, you could also write this just as 11 over 15 or negative 11 over 15. You can certainly write it out like that. I personally like that plus or minus sign in front. It saves us some time. It's easier to see it, I think. If I have an equation that has a cube in it, I'm going to use cube roots to get rid of that. So the cube that's on the x, I would, if you just do this and you just say, oh yeah, I know that it's going to be a cube root, it's not a cube root right now. You have to make sure that that 3 gets into that corner. That's called the index. So the cube root of 125 is just 5. Notice I didn't write the plus or minus part because I can't use both on this. Positive 5 works. 5 times 5 times 5, 125. But if I had a negative 5, negative 5 times negative 5 is positive 25, times another negative 5 would be negative 125. That's not going to work here. So I have to just have the one answer. So cubing the x, I would use a cube root and a cube root. So I get my x, that's what I wanted. This one, because it's a decimal, there are 3 numbers after the decimal. When I take a cube root, that gets divided by 3. There'll be 1 number after the decimal, so it'll be a decimal. And then the cube root of 64 is 4. Remember I said 64 is the tricky one because it's a perfect square and a perfect cube. All right. The cube root of, x cubed equals 27 over 64. So I would take the cube root to get rid of the cube. So I'll get that x equals, the cube root of 27 is 3. The cube root of 64 is 4. So it's 3/4. Just more problems just like those last ones. Again, when it says show all work, there's not a ton of work to show. It really is just drawing in the square root, since it's a square root plus or minus. So x is going to be plus or minus 3. Square root, plus or minus, and I drew over the decimal again, I'm sorry. This is going to be plus or minus 0.2. 2 numbers after the decimal, 1 in your answer. Square root, plus or minus. X equals, the square root of 36 is 6, square root of 49 is 7. Sorry, that got kind of squished right there. The cube of x is 8, so then the cube root, notice, not a plus or minus. Oh, I forgot my plus or minus on this one. Plus or minus. Sorry about that. What if I rewrite that answer a little bit bigger so you can actually read it? So, using the cube root, I get that x equals just 2. Cube root here. X equals, cube root of 27 is 3. Cube root of 64 is 4. We just did that one. Okay. This is a totally reasonable problem, right? Everyone knows the number of square meters of a park that you're going to jog around, but maybe not how long the side length is. Yeah, this is a ridiculous problem. I'm sorry. It says that Jordan jogs around a square park every day for exercise. Her track coach asked her to log the distance she runs each day. The only information that she can find out about the park is that it's 495,616 square meters. How far does she run each day? Okay, so the area of a square we know is just the side length squared. So we're going to put our number in that we know for the area. And then we will, you're going to see in the next slide, square root, and then we'll have to put the plus or minus right here. Now, the square root of 495,616 is obviously, yeah, I for sure just know this off the top of my head. Yeah, obviously. Plus or minus 704 meters for each side of the park. However, so we made a big deal, like, oh, don't forget the plus or minus. However, this is a side length of a square. I can't have a negative number for that length. So yes, when I'm solving the equation, I need both of them. When it comes down to it in terms of reality, that is not going to be a negative length. It's only going to be that each side is 704 meters. So the side of each of the sides of the park, and that doesn't want to move for me, is 704 meters. And then that means the perimeter, I would just have to multiply that by 4. So the perimeter is going to be, I don't know why this is not working for me here. 704 times 4 is 2,816 meters each day. And it's not working well for me here. My computer's getting cranky with me, I think. Okay. If I know the volume of a cube is 1,728 cubic centimeters, I want to find the length of each side. So I would substitute my numbers in, right, 1728, and then I would say, oh, to get rid of the cube, I would use a cube root on both sides. And the cube root of 1728, again, obviously everybody knows this number, right? Sure. Is going to be 12. So this would be 12 centimeters for each side. Okay. So today we are going to have another worksheet. It is solving equations that have squares and cubes in them. So we're going to be using square roots and cube roots to solve the equations. However, the worksheet is rather long, so I'm just going to assign the evens. And actually at the end, there's kind of a bonus question that you can try if you want to. You certainly don't need to try it because it does have some rather large numbers that you'll have to do a little bit of thinking about. But go ahead and check that when you're done in Schoology, and then make sure that you take the learning check. Let me know if you need any help.